In remote meetup. Welcome back to everyone who joined us last month's meetup, and as a new hello to all the new attendees who are coming for this one. We have two great talks lined up tonight, so there's plenty of meat on the bones of these talks, I think. So I'll try and get through this quickly. And the first bit will be just to thank the speakers. Or the sponsors, sorry. We have Cloud Shuttle and JetBrains and Teamwork, and also myself at Vistas Recruitment. All without whom this wouldn't be able to happen. So thanks very much to the sponsors. Just like last month, if you were here last month, we also have, as Alan just mentioned, we have a raffle for everyone who's here tonight. So if you want to grab a screen, grab that code, the VR code there, or go to that link. You can fill out a short form, and Alan will run a little Go routine that'll pull your name out of a hat, and you can win a JetBrains license for yourself. We've got one license to give away this month, and I'll announce the winner after the two talks have happened. So with that, we're on to, I think it's time to get moving here and get on to our first talk, which is be given by Daniel Marti. Daniel's been working with Go since 2014. He's been contributing to Go since 2016. He's a big member of the community. So he's also the founder of the Sheffield Go meetup and runs that regularly on a monthly basis. And I've seen him give many talks at different conferences around the world. So we're delighted that he's chosen to agree to speak to us tonight here in Belfast. So without further ado, I will pass you over to Daniel, who will be talking about a deeper dive into Go's build cache. Over to you, Daniel.
Cool, thank you. Is my voice clear enough?
Yes, perfect.
Cool, so let me just share my screen. So everybody should be able to see my screen now, that's good. So the talk today is going to be essentially a deep dive into Go's build cache. So I'm going to start by taking you back to 2017. So welcome, Go 1.9 just got released. And nobody knows what modules are. That's nonsense. Everybody just develops code in the Go path. And Go's build cache works fine. So let's go use it. I've got a little demo set up. So essentially, I've got a Go path here. So you can, if I do Go path, you can see it's this one here. And I've got a little package here that I'm going to be trying to build. And what I did before the start of this talk is I essentially downloaded Go 1.9.7, which is the latest release of that major version. So we can run it and see that it works. And we can build a package. So if I do this, you can see it builds. And the -v flag, what it does is it essentially tells the Go command, please tell me each of the packages that you're building. So we just go on about our day, we rebuild packages, and we notice that the build cache doesn't appear to be working properly. So anytime I ask, please rebuild this package, it just keeps rebuilding it, even though I haven't changed anything. So to actually make it not rebuild when it doesn't need to, I need to use the I flag. And that still doesn't work. And that's kind of confusing because the -I flag only works for dependencies. So what I actually need to do is install. And if I run that twice, you can see that it no longer has to rebuild that package. And that's fine. And for many years, people had to remember this distinction. You have to use go install if you want your builds to be fast, because otherwise you're going to be rebuilding the same packages over and over again. So that's fine, but it also has some other problems. So for example, if I don't modify any of the source, but I basically only change the timestamp of one of the files, it's going to think it needs to rebuild the package, even though the package didn't change at all. And for example, if I check out one version and I install it, it's going to build it, and then it's going to be cached. That's fine. But if I check out a different version and build it, again, it's going to build it and cache it. That's also fine. But if I go back to the old version, you're going to notice that the old version that was cached before got evicted now. And the reason for that is because, and we can actually see it with the list command. So the list command tells us information about a package. And with the JSON flag, it gives us more information about the package. So if we do this and we go up a little bit, we can see the target line. And the target line tells us this is where I'm installing the package that you told me to list. So you can see that this is only namespaced. The path for this cached compilation is just the path of the package. So if I build two versions of the same package, they're essentially going to replace each other. And that's kind of annoying. And another problem here is that the cache is only within the current Go path. So if I have, for example, a Go path for one project and another Go path for a different project, they're not going to share any cache at all. They're going to cache packages separately, even if the versions are the same. So overall, this build cache is not all that great. It works okay, but it's very basic. Like we said, the problem number one is that Go build by default does not cache, and that actually bites. It used to bite a lot of people. If you didn't know you had to run Go install, you might think, why do Go builds take so long? The problem number two is that it's based on file modification times. So even if I, like, for example, if you change a file but don't change its timestamp, it would think that nothing needs to be rebuilt, which is wrong. And it's only one cached build per package, or rather per package path, even if two versions, you want to keep them cached at the same time. And there's no sharing between Go paths. And having all of your system use a single Go path is possible, but then all of your builds have to use the same versions of each package, which is kind of difficult if you work on multiple projects at a time. So let's jump ahead about 6 months, and now Go 1.10 got released. And if we look at the changelog for that version, one of the major changes that it came with is a new build cache. And it says the Go build command now detects out-of-date packages purely based on the content of source files. And modification times are no longer consulted or relevant. It also says it now maintains a cache of recently built packages separate from the installed packages. So this means outside of Go path. And the old advice to use the I flag or to use Go install is no longer necessary, because Go build by default now just does the right thing, which is caching stuff. So that sounds better. Let's go try it out. And essentially, we're going to try the same stuff we did before, but with a different Go version. So just to be sure that we don't keep any stuff around, I'm going to delete existing cached packages from Go 1.9 and Go 1.10.8 version. So we verify that it's a version we expect, and then we can do the same stuff. So we check out one version. We can build it, and the changelog told us that we no longer need to worry about the I flag or the install. We can just use Go build. So let's try it. So the first time it builds, second time it does not. That looks good. And then we change to version 2.6.4. We build. Huh. That's interesting. I was expecting it to build, but I guess this package didn't change between the two versions, but that's a good sign. Changing the timestamp of the files, let's see. Changing the timestamps of the files as expected does not force a rebuild. And Go 1.9 also had another problem, which is that, for example, if we do install, it just builds the package as expected. But what if we want to rebuild it with some build flags? So for example, I want to build it with the race detector enabled. Sorry, no, that's not what I want to do. So let's try to build it with a compiler flag, or even let's use something silly like a bad flag. So this should normally error, but it's not, because it does not realize that this flag should force it to rebuild the package. And Go 1.10 also fixes this. So if I do gc flags, bad flag, it's going to fail. And it's going to tell me up here, flag not defined, bad flag. So it looks a lot better. But now the question is, how does this new cache work? Because we've seen sort of the high-level explanations of why it fixes some of the issues that we had, but not how it works internally. And the short version is hashes. So you can think of the inputs to building a package. You've got the source code of the package itself, the Go files, for example. You've got the build flags, such as the raise flag or GC flags, something, something. And you can also think of the metadata around the package, such as the dependencies and the versions of those dependencies. So I'm going to simplify this a little bit, and I'm going to say source, flags, and dependencies, because those are the main ones that people interact with. So you can hash those, and you can think of a hash like SHA-256. It doesn't really matter for the purpose of the explanation. And then you can say that the hash of all the inputs is essentially the hash of the package as it should be built, right? And then what this new Go build cache does is it calls this hash of the inputs an action ID. And an action ID uniquely identifies a build action, such as, for example, compiling a library package. And I say uniquely because if any single thing changes from the inputs, then the hash is different, because that's how hashes are supposed to work. So if the action ID matches what's already stored in the cache, then that's a cache hit, and then you don't need to redo that work. And this works as long as actions are reproducible. That is, if you have the exact same inputs as you did yesterday, then the output should be exactly the same as yesterday. If anything changed between yesterday and today, then the cache wouldn't really make sense, because you would have to redo the stuff, the work, to then realize if the cache should be a hit or not, and that sort of defeats the purpose. And Go builds are reproducible in that way. And for dependencies, you can think of the hashing as a sort of tree of hashes. So for example, suppose that you're building a main package, a program, and it depends on a library, which depends on 2 standard library packages. So suppose that I demodify the strings package. So if I modify the strings package, I need to rebuild it, right? But I also need to rebuild the packages that import, or rather depend on the strings package directly or indirectly, because they might change behavior. So essentially what the hashes do is that because they flow, so for example, the hash of strings is an input to the hash of the library, then all the hashes downstream also change. So then the Go command has a very easy way to tell, oh, wait, I need to rebuild these 3 packages, but I don't need to rebuild IOUtil because its hash is not affected. So this is the main content of the talk. And now I've got an addendum to talk about ways to poke at the build cache. So I could either talk about that now, or I could take some questions and then talk about this right after.
Okay. Have we got any questions for Daniel at this stage? If you want to drop them in the chat, and then I can read them to him if there are any questions.
So I'm going to show the first trick to poke at how this works internally. And meanwhile, maybe some questions are going to come in. So now I'm going to go back to a recent Go version. So this is a Go master version from yesterday. So it's 6 versions newer than the one we just used. And let's go to the same project as before. So we can see the same behavior as before. If I do Go build, the cache works as expected. If I change the flags, then it's going to do something different. If I touch one of the files, it's not going to rebuild. It's all the same stuff that we saw before, but newer versions of Go are a little bit smarter and can tell us more things. So for example, I can do Go list JSON. And it's still, it can tell me if the current package is stale. So in this case, it tells me it's stale because it's not installed, but it is available in the build cache. It doesn't actually tell me where it is in the build cache, but we can actually find where it is. So the location of the build cache can be queried by goenv go cache. So if we go there in a different window, let's actually remove everything. And what we can do is just rebuild. And then if we look at, and then if we look at the files in the build cache, you can see that it's essentially like a block store of hashes. So it first does a 2-letter prefix. I think this is hexadecimal. And then it says, for each entry of a hash, then this is the hashed content. So you can see there are a few entries, and one of those is the package we just built. And to find where that is, what we can do is remove everything again and use the X flag. And the X flag tells us roughly what the action is doing. And at the end, you can see I ran the compiler. I compiled a bunch of Go files. And then I copied the resulting archive, the resulting compiled file, into the build cache. So you can see the build cache here. And then this is the hash. And then this file, if I go look at it now, so it's a 2.4 megabyte file because it's the compilation of the package. And I can also ask it directly. I could do go list JSON with the export flag, and the export flag is going to make it also fill a field called export, and that points to an up-to-date cache entry for this package. So it's the result of building this package. So that's pretty neat. And the other thing that I wanted to show is that there's a Go debug. There are a bunch of Go debug values you can pass to Go to alter how it works. And one of them is sort of the debug mode for the caching system. So if I do go debug, go build, you can see that it prints a lot of stuff, but let's just look at a few lines, for example. So here it's trying to figure out if it needs to rebuild the syntax package, which is the package we're currently in. So first it says, it takes the hashes of a bunch of things, such as the version of Go, what directory I'm running in, what GoOS and GoArch I'm running in, what version of the compiler, the hashes of the input source files. So for example, somewhere in here is nodes.go. I'm not finding it. Yeah, there we go. So this nodes.go file that I was touching earlier, this is the hash of the contents. And it also hashes the imported packages. So this is the hash of the compilation of the buff.io package, which syntax imports. And then all of those hashes get hashed into the final thing, which is this. And then this is the entry in the build cache for the syntax package. And then it just realizes that nothing needs to be done because this file already exists in the build cache. So that's pretty much it. The only other thing I could talk about is that the Go test cache also exists, and it works in a very similar way. It actually uses the same system. If you run, for example, if I do go test dot.
I have a question, Daniel. Do you want to?
Sure, go ahead.
Yeah. So if you have a large code base with many packages, would it rebuild the entire thing if one file changes within the package, or does it read the cache for those packages and then just rebuild the changed one?
So what you could call the build unit in Go is a package. So if you change a single file within a package, then the whole package needs to be rebuilt. And any packages that depend on that package directly or indirectly should also be rebuilt, if that makes sense. And that is sort of what I tried to explain here. So in this case, I think I have a pointer here actually. So in this case, if I modify the strings package and then I build main, I need to rebuild these 3 packages, but I don't need to rebuild IOUtil or any other dependencies that are not related. And what I was going to say about testing is that if you try go test with arguments, it's going to cache the results of the test run. So in this case, it took 0 time to realize I've already run these tests and I don't need to do anything. I can just tell you that they succeed. And the way this works is the same. It just hashes the test source code and essentially roughly what the tests do, and it just puts that in the build cache. And I can tell it no. If I use count equals 1, I can tell it no, I actually want you to run the tests, and then it does. But if I remove the argument again, it's just cached, and it's the same system. Is the build dependency done via the import keyword? So the input keyword is essentially importing a package at the language level, and then the Go command, when you ask it build this package, it loads the packages and follows those import declarations, and then it sort of builds a graph internally to realize what needs to be rebuilt or not. So I guess yes, but it's only like looking at the import list is only the first step. You have to do quite a lot more later to hash the inputs, hash the files, and so on to realize what you need to do. And all of that is done by the Go command. You don't have to worry about it. That's a very good question. Does the Go test cache take into consideration other files like the test data directory? So yes and no. It does something kind of cheeky, which is, I'm going to try to find the source code for this. So there's a package called testlog. Open. So essentially, testlog is a way for Go test to realize what input and output actions you're doing inside a Go test. So for example, let's go and have a look at func open. So if you look at the source of open file, the first line looks very weird. It says testlog.open. And testlog.open, it says, do I have a logger? Then log that I'm opening. And again, that doesn't make a lot of sense, but oh, this is implemented in a different package. So roughly what this does is when you run a bunch of tests, then this call to testlog.open tells the testing package, hey, I'm opening this file. And then that file is included into the hash of the inputs. It's included into the list of inputs, basically. So this is not foolproof. If you, for example, open a file directly through a syscall, not using os.open, then it's not going to work properly. It's probably not going to cache too aggressively without using that file. But in general, it just works, and that's fine.
Okay.
Any last question?
Any other questions for Daniel? Oh, there's one. Are there any major
bugs with the current caching system that you know of, similar to those of 1.9? Some bugs were fixed in the few releases following 1.10 because it's a very large refactor. Recently, it's mostly been fine, I think. There are some funky interactions between the build cache and some flags. Like, for example, there was recently toolexec build cache, but I'm going to try to find this issue. So there's this issue that I filed a while ago. And essentially, it's because the toolexec flag is a build flag that lets you a sort of man in the middle, the compiler. So you can say, instead of running the compiler directly, run it through a command that I tell you. And then this command can do anything you want. So here, for example, I could do go build toolexec equals time. And it actually does nothing. And it does nothing because the build cache does not include time inside the hash. So what I need to tell it is -a, which is equivalent to please rebuild everything. And then it actually runs the time command for all the packages it builds. And this is kind of silly, but it tells you how long it took to compile each package. So you have to be careful sometimes with the build cache, because some things are part of the build cache key of the hash, and some things are not. And you have to read the documentation for that. But in general, if you do basic things, it just works and you don't have to think about it.
Okay, any other questions for Daniel? It looks like, I think, well, here's another one. How big can the cache grow to? Is there an upper limit?
So I think when they designed the caching system, they were asking people how large their GoPath directories were to sort of get an idea of how large people expect these caches to get. Because if you set the limit too low, it's not going to cache enough. It's going to evict too quickly. And if you set it too large, people are going to complain that their disks are full. So I think they just ended up running some statistics and sort of deciding on a general limit that people are going to be okay with, and people don't complain, and it's been fine so far. If you think it gets too big, you can run, I think it's go clean cache, and this deletes the go build cache directory, which I did manually before. I don't think you can change the cache size, the default heuristic of should I delete things from the cache or not. I think there was an issue filed about that a while ago, but I'm not going to be able to find it right now. And we might be out of time.
Cool. Any other questions? We might have room time for one more, maybe. Looks like we might have exhausted the questions, Daniel. Thank you very much. It was really interesting talk. Thank you indeed.